Okay, so let's review all the ways to factor. What are all, you can factor, the first thing you're gonna do is factor out a GCF. So for example, in this problem right here,
Take out of that.
take out a 5x squared. That's one thing you can do. Another thing, if it's a quadratic trinomial, you can do one of these where you do the AC method, or you guess and check. You can do that. Remember perfect square trinomials? Remember that? And if it's the difference of two perfect squares,
I went on Cayenne and they do that. Khan
what?
Academy.
Khan
Yeah, I
Academy.
went on there
Mhm.
and signed up and stuff.
The difference of two perfect squares is x minus x plus. You can do factoring by grouping, or this one we have to spend some time on, the sum or difference of two perfect cubes, okay? But I'm gonna hold off on that for a second. I want you to look at your first example right here. It's asking you to solve the equation. And they're asking for real and imaginary. You have to do both. So, what is the first step when we solve these equations?
Yeah.
Get everything to one side. Yes, get standard form. You're gonna get this 3x to the other side. You want a 0 on one side. Now, what's the first type of factoring you should always see? GCF. Is there anything you can take out?
X.
Take out an x. What's left?
2x squared.
2x squared
Minus
minus 5x minus 3. Bless you.
Thank you.
Now, you want to break this up into as many little pieces as you can. This is already, that's broken up. Now you got to look at this. How would you break this up? Well, this one is the guess and check one. Now, because these two numbers are both prime, it's very easy to guess and check on this one. You've got 2x and x. Now, we need a 3 and a 1. One of them has to be negative. And I want the outer and the inners to add to be negative 5x. So it makes sense to put a negative 3 here, because 2 times negative 3 is negative 6, and a positive 1 here, because then if you add, you're going to get negative 5. Does that make sense? Now I need to bring this down. Check this out. It's broken up into 3 pieces. There are 3 zeros in this problem. For every variable, you will have a 0. So what you do is you set each of these equal to 0 and solve. So what are my 3 answers? For every variable, you'll have an answer. What's this answer?
0.
X equals 0.
Negative 1/2.
This one, we know 2x, if 2x plus 1 equals 0, if we subtract 1 and divide by 2, x is negative 1/2, and this is x equals 3. Now, I want this to make sense to you. I'm going to add one more thing onto this. When we go to graph, you're going to eventually have to graph this. We just talked about the shape of this. Okay? It's a polynomial. What is the left and the right side going to be doing? And how many turns are there going to be?
Which one is standard?
It is. This is in standard form.
Oh, I thought you were pointing to the
Well,
top one.
it's the same 2x cubed.
It's gonna be 2 turns.
There's going to be 2 turns.
It's gonna
And the
Both
left
going
and
the
the
same
right
direction.
side, so it's gonna look like this. It's gonna be 2 turns. And I'm gonna tell you this right
goes
now.
up.
See these 3 right here? These are called your zeros. They are gonna cross the x-axis. You're gonna have 3 turns, or 2 turns, I'm sorry, 2 turns. And it's going to hit at 0. And it's gonna hit at 3. And negative 1/2. So what's going to happen is my left and my right side, it's going to look something like this. So, do I have 2 turns?
yes.
Yes. Is my left going down and my right going up? Yes, they're opposite. And these are the x-intercepts, that's what you're looking for. Does that make sense?
Yes.
So this is help as to what your graph is going to look like. Okay? There's more to it, but I just kind of wanted to give you a reason why you're doing all this stuff, okay? Let's try the next example right here. What should we first do? Move everything where it needs to go. See the 6x cubed, where should it go?
Between the 3
Yeah.
Mhm. 12x squared equals 0. Is there anything we can take out?
3x squared.
Good job. 3x squared. What's left? X squared minus 2x plus 4. Now, check this part right here.
Simple factoring.
Is it really simple factoring? Do you know what times what is 4 but adds to be negative 2? I don't. So what are you going to do? You still have to factor it. You're going to either use the quadratic formula or you can complete the square. So I would complete the square. Why? Because this is a 1 and that's an even number. So let's do that. X squared minus 2x plus 4 equals 0. How do you complete the square? Subtract 4. You take half of this number and square it. So that's going to give you a 1. You're going to add 1 to both sides. Whoops. X minus 1 squared equals what? Negative 3. How do you finish this? Square root of both sides. X minus 1 equals plus or minus root 3i. And x is equal to 1 plus or minus root 3i. Now, what does this mean? It means with this I in here, this is an imaginary number. This is an x to the 4th power. This means that when I'm graphing this, I can tell you this right now. These are going to cross. This 0 is going to hit right here on the x-axis, but these two zeros are not going to cross. They're floating up, okay? It's not hitting the x-axis because of that I. So what are your zeros? We have 0, and we have 1 plus or minus 3 root I. Now, why did I draw this in such a way that it's not, it's actually going to be touching at 0, like this, but not crossing through, because the multiplicity of that is 2. And we're going to talk about that on Monday.
Because then you get a negative. You can't have a negative.
Yeah,
You
you-
change it to an
Next. Right, next one. Number 3, what should I do? Move. Is this factorable? Is this one factorable? Do you know what two numbers multiply to give you negative 4 but add to be negative 3? I do. We did these a while back. It's going to be negative 4 and positive 1. Do you remember this? It's been a while. X squared times x squared is x to the 4. And then if you FOIL this out, you're going to get negative 3x squared, and 1 times negative 4 is negative 4. Do you guys remember doing this? Okay, now what should we do? We're going to set each of these equal to 0. You're going to say x squared plus 1 equals 0, and you're going to say x squared plus minus 4 equals 0. Now remember on our chapter test, we took the square root of both sides? How do you solve these two? What do I do with this 1? Get it out of there. Subtract 1, and then take the square root of both sides. So what's your answer? X is plus or minus 1i. Good job, Sam. Plus or minus I. How about this one? X squared
X
equals
equals 2.
4. Square root of both sides, and what's your answer? Plus or minus 2. Questions?
Yeah, that's also the difference of two perfect squares.
Yeah, it is. You could have, yes. Everyone see this? You could have done right here, instead of bringing 4 over, you could have done x minus 2, x plus 2, and then x is 2. Did anyone do that instead? You can.
That's for my mind. Well, I just noticed all perfect squares now.
Okay, before I do number 4, I'm gonna save that one for last. That is a type of factoring we haven't done, and I'm gonna be spending some time on that one. I wanna do number 5, because I think you can do number 5. How do you do number 5? X cubed, we're gonna do minus 3x squared plus 4x minus 12 equals 0. Now, do you remember factoring by grouping? There's 4 terms here.
Yeah, don't you like put your finger over
Yep, I put my finger over these 2. What's common?
X
X what?
squared.
X squared, and you're left with?
X.
Good, x minus 3. Now, what's common here?
4.
A 4, and you're left with? Okay, now what? See, these 2 are the same. Pull that out, x minus 3. And you're left with
X squared.
X squared plus
x squared plus 4 equals 0. Now, this is good. One of your zeros is 3. But what do we do here?
It's near.
You're gonna
Plus or
set
minus 2
this, good, set that equal to 0, subtract 4, square root both sides, and you get x is equal to plus or minus 2i. So what are your zeros? 3 and plus or minus 2i.
How would you graph that to?
Well, these 2 are gonna be floating. It's gonna be like, you're gonna hit, I know that this is x cubed, so it's gonna go like this. It's gonna hit at 1, 2, 3. It'll be something like, it'll go like this, like that. It's gonna go cross at 3, and these 2 are not gonna hit the x-axis because of that imaginary number. All right, now this last one. This is going, you get 27 on the other side. Now, not last year, but in your freshman year, I know you guys did the sum or difference of 2 perfect cubes. And let's review it. And we didn't do any of this factoring. So what we have here, I'm gonna give you a simple one first. Whoops.
8
Hey, how'd you know I was gonna do that?
is the easiest
Because
one.
everyone does that one, right? Okay, now this could be a plus sign or a minus. I'll do one with a minus first and then one with a plus. Check this out. What 3 numbers, this is a perfect cube. Why? Because we have 3 of the same number that multiply to give you x cubed. And this is a perfect cube. Why? Because 2 times 2 times 2 is 8. If you have 2 terms, and this sign is either a plus or a minus, and they're both perfect cubes, not perfect squares, perfect cubes, what you're going to have here is a binomial and a trinomial. In the binomial, you're going to have one of each of these, and whatever sign this is, it's going to be that sign. So it's going to be x minus 2. Now right here, you're going to take these 2 and multiply them together. You get x squared. You switch this sign. If it's minus here, this becomes a positive. You're going to multiply one of each of these together. You get 2x. And then this sign is always a plus sign, and you multiply these 2 together to get 4. Now what you're going to have to do here is solve this. I would set this equal to 0, this piece right here, and I would complete the square. I would subtract 4. Half of 2 is 1, square it. You're going to add 1 to both sides. Factor. square root, and I'm going fast because this should be very easy, root 3i, and then subtract 1. This is nothing new. This is what you just took a test on. So what are your zeros? It's -1 plus or minus root 3i and 2. Huh? Now, what if it were x cubed plus 8? It's x, 2, 2, 2. And so you'd have, in your binomial, you'd have x plus 2 instead of x minus 2. And then this would be x squared minus 2x and then plus 4. You get it? So one of your answers would be -2 and then you do this one. So let's do this example. I know you guys have done these before, but it probably is a while. So now, this one is the difference of two perfect cubes. How do I know that? Well, because 125 is 5, 5, 5, and x cubed is x, x, x. So does everybody agree that 5x times 5x times 5x is 5x cubed?
Yes.
Okay. How do I know 27 is a perfect cube? Because 3 times 3 times 3 is 27. So what will you have with this? You're going to have a binomial and a trinomial. In your binomial, you take one of each of these and drop them in this order. So it'd be 5x, and whatever this sign is, if this were a plus sign, it'd be a plus, but it's a minus. So is everybody cool with that? Okay, now you take these two and multiply them together. What's 5x times 5x? It'd be 25x squared.
Plus.
Switch the sign. This is the only time you switch it. Now multiply these two together. Don't look at the sign. What's 5x times 3? 15x. And then the last is always a plus sign, and 3 times 3 is 9. Now, for this 0, what is it? It's 3/5, right? 3/5. What are you gonna do for these two zeros? There's nothing to pull out. I would definitely not complete the square on this, because if you divide it by 25, that's gonna be a fraction. So I would definitely use -b plus or minus the square root, and you have to do this, because it's asking you to find all the zeros, real and imaginary. So what you have here is -15 plus or minus 15 squared minus 4 times 25 times 9 over 2 times 25. What's 2 times 25?
50.
50. So let's do this, okay? What should we do? We're gonna square 15. What's 15 squared?
225.
225. So I'm running out of room, so I'm gonna write up here. It's -15 plus or minus 225. And I noticed that a lot of the errors that I saw in your test were due to neatness
Oh,
and order of operations, and it was no surprise, but what is 4 times 25? It's 100. What's 100 times 9? 900. Okay, let's finish this up and then you guys are going to lunch. It's 225 minus 900. You get -675.
Take out 5.
Wow. This is a,
biggie.
Oh, no, wait, you can take, no, you can't.
we have to factor this -675. So off to the side, I'm gonna make a factor tree. And I know 5 goes into this. 675 divided by 5 is 135.
It's 225 by 3, and you break down 225 to
27.
15.
I had 25 times 27, that's what I started with, 25 is the bigger.
So that's what I get. Did you get 2 5s and
Yep.
3 3s? See, it doesn't matter how you multiply.
Well, I
So
stopped at the 25 and the 9, because I know they're perfect squares, I can pull them out.
So there, you
Uh-huh.
can take out a 5 and a 3, which is 15, so it's 15I root 3. Does everybody agree with that? That negative 675 is 15I root 3. Is there anybody lost? 5 times 3 is 15, and there's a 3 that's not left, or not paired up. So this is what we have, negative 15 plus or minus, and then over 50. Now, is there a way to simplify this answer? Is there a number that goes into all 3 of these? 5. 5 goes into this 3 times, 5 goes into this 3, and 5 goes into this 10. So your best answer is negative 3 plus or minus 3I root 3 over 10. Does everybody have that? Okay, so tomorrow, I hope you have your notes, and if you didn't understand anything, this will be on YouTube. Have a nice Halloween. Be safe, you guys.